What's going on, guys? Today we are going to be working on a 2024 SeaDoo RXT-X 325. This is the fiery red model. This ski came in. It already has quite a few bit of Riva modifications on it, but the owner's looking to take it to the next level, so I'll show you what we have in store for this. Alright, so just working our way down, we're going to be installing a depth finder. We're also going to be upgrading to the unlocked ECU so we can flash the stage 2 tune once we're all finished. We have the Riva intake with the tile blow-off valve. We are also going to be doing springs and retainers. That's the titanium upgrade. We also have a Solas 1419 impeller and a stainless wear ring that's in the freezer right now. We have a Riva camshaft, the Riva high pressure fuel rail with all the supporting hardware for that. We have the Airbox delete kit, upgraded injectors, additional keys we'll be programming. We have upgraded valves and the valve stems, seals and all that stuff. We have the upgraded pump wedge. We have the 325 intake manifold girdle. We're going to be doing some ventilation mods, whole ventilation mods. We're going to be installing some frog skin just like I did on a few in the past. We also have the Riva upgraded intercooler. Next we have the JP Racing reinforced fiberglass pump tunnel. I'm also going to be reinforcing the front of the ski in the bow area using same thing as I did on mine, 1708 biaxial fiberglass, and of course the Total Boat high performance 2-to-1 resin. And we're also going to be doing the Riva intake manifold upgrade kit. And of course along the way we'll also be doing the basic stuff that we do. We'll check out the IBR stops, see where they're sitting, and then we're also going to do a boost leak test to see if we have to do anything with the intake manifold studs. So this will probably take a few days to knock out, but the first things first, I got to get the ski in the garage. So I'm going to start prepping some stuff. I might just knock out the jet pump real quick, just to get that kind of done and out of the way. And then also I'm going to show you guys, I don't know if I'm going to put it in this video or maybe I'll do it a separate video, but I'll show you how to do the drive shaft removal on a 325, which has a nut on the stainless steel hat, or on the C-clip that holds the drive shaft in for the carbon seal. On the previous skis you have a special tool, which is this guy up here. I'll have to do a video on that at some point, but you basically push on that stainless steel hat to get it out of the way. And on the 325 there's a special wrench that you use with a support bracket and then a nut that goes on the drive shaft to crack that nut loose. So I'll show you how all that stuff works, but first things first, let's go ahead and bring the ski in the garage. Alright, I've decided I'm going to pull the pump first, just because trying to get this thing into the garage on a cart is really a two-person job. So I'm going to pull the pump, waiting until my fiance gets home so she can help me pull this. So let's go ahead and get this taken off. And here is our jet pump. Very clean, very little nicks on the impeller, just small amounts there. Wear ring looks absolutely incredible. Actually kind of looks brand new to me. So this is good. For the jet pump, we are going to be replacing the impeller. We're also going to be putting a stainless wear ring in, and we're going to be updating or upgrading the pump seal. But mainly wanted to get the pump off because we will need to have access to the drive shaft. Like I mentioned earlier, we do have this drive shaft nut, which will go on the end here, and that will let us kind of twist to get that nut off where the carbon seal is. The drive shaft will have to come out in order for us to install the JP Racing jet pump tunnel reinforcement, but there's a few other things that we have to do in there as well, so it's just going to make more sense to get the jet pump out of the way first. So I'll probably do the jet pump rebuild tomorrow. For now, I'm going to continue on taking apart things that need to come out. The intercooler is coming out, the hoses are coming out. We'll take off the intake because that's going to be in the way, and we'll work our way forward as well. We are also doing the reinforcement up here, so I'm going to start taking these plastics out as well, and we'll just start working our way around. So unfortunately with this video, because there is so much getting installed, I will be jumping around. So I'm not just going to commit to one piece because, you know, like I said, there are parts in here that depend on the other parts. So it's going to be a little bit of a all over the place kind of video. But with that being said, that's how these things go. So let's go ahead and get the intercooler out, and then I'll start breaking down the plastics up here to get those out of the way. By the way, guys, the clamps that were on the supercharger outlet and the throttle body inlet were crazy loose. I'm pretty sure this thing was leaking boost. It's just, I mean, it's crazy how much you really have to kind of check the hose clamps on everything in here, especially the water lines, because, you know, here you have your fresh water inlet coming in from the jet pump, and if any one of those hose clamps comes loose, you know, this thing can sink very quick. So it's a good thing we did that. Next thing I'm going to do, intercooler's out, I'm going to go ahead and start pulling out the plastics inside here just to get that stuff out of the way. We're making progress here. I'm not going to go into too much detail on the bin removal, just because I did make a video about that already, but we're going to go through the same process. We'll cut these zip ties, remove the screws around the bin. We'll unscrew the base of this guy here, or it's up here, I think. We'll get this loosened. Don't forget to reinforce this with some rope or something, just to keep it from falling on you, and then we'll be able to lift the bin out. So I'm going to do that now. Alright, so I have the bucket partially out, and I don't remember if in my last video I mentioned when I was disassembling my ski, the first time you take the bucket out, you will have the intake tubes that are zip tied to the bottom. You can see it right there. So you just have to cut those zip ties, and then the bucket will come right out. I'm going to do that now. And just like that, the bucket is out. So we have easy access to the front here, so I can take the foam out and do the reinforcement there. But more importantly, we also have direct access to the Airbox and the ECU, which is important because we are going to be doing a Airbox removal on here, which is also going to make the ECU replacement quite easy as well. So I'm not going to do the fiberglass part on camera just because it's kind of messy, and I already covered that. It takes up a good amount of time, so I'm going to knock that out, and then I think what we'll do next is move on to the Airbox removal, just because it's much easier to do that when the front bucket is out. So I'd rather get everything done up in the front so that I can put the bucket back together, and then I'll just focus on the back of the ski. So I'm going to go ahead and do the fiberglass, and then I'll probably pick this video up tomorrow. Alright, it's the next day. I started the process of removing the wire harness from the Airbox. We have to disconnect the GPS, I believe that's the GPS. The fuel system has to be disconnected, so we got that disconnected there. We broke all the zip ties here, started disconnecting. Fuse box is removed, starter relay is removed. Rectifier, voltage regulator is also disconnected, so we're getting ready to pull all this stuff here. And of course the coolant is also disconnected as well. I believe, I forget when I did mine, or the other 325 I worked on, I believe the Airbox is going to go from the rear forward. On the 300s, it's actually split in half and taken out this way. You can take it out the front way, but generally most people just take it out from the back here. So on the 325, it's usually best to go front, which is why I have the fuel filler neck also still removed. Of course, this is bolted down onto the tub. It's threaded inside here, so it's very easy to get out of the way. I do not recommend removing the stem, because if you get debris in there, that will be a nightmare. So we'll just leave that connected, and obviously it's on a rubber hose, so it's very flexible. We can make that work. So I'm going to go ahead and finish up removing the electronics from the Airbox so that we can pull that out. Alright, and that is with the Airbox out. Certainly a lot more room. You can see all the way down to the oil cooler, which is just under the intake manifold. I did have to disconnect the fuel line to get the lower portion of the Airbox out, but that's just a snap fitting, goes right back in. So I'm going to get the rest of the retainer straps for the factory Airbox out, because the Riva upgrade does come with its own. So I'm going to pull those out, and then we'll move on to the next step. Alright, so before we put the new box in, we're going to relocate the fuel pump relay So it's just one nut that's holding it in here. We'll move that, and that's going to sit right in this pocket just under the diagnostic cable port. So I'm going to move that now. As you can see here, we started installing the new plate that the ECU and everything's going to sit on. This one's kind of hard to get on video just because you have to twist and contour and everything. It's just a very tight fit. But I did get the fuse box mounted. It just mounts on with 4 self-tapping screws. So I'm going to go ahead and roll this over, and then we're going to get the regulator mounted on here as well. So it's just a kind of a tight fit, but I'm going to do my best to try to get this on video. Now we're at the point where we need to reinstall the ECU. Now obviously we're going to be upgrading to the Riva unlocked ECU. So what I'm going to do is I'm going to install this ECU. We still need to have this ECU accessible because in order for the map tuner to program it, to program the new one, we need to be able to copy the data off of this one. So at first I was just going to install this ECU, do the programming and whatnot, and then replace with the new one. But I think what I'm going to do is just install the new ECU, get the rest of the ski and everything done, and then when I'm ready to do the programming, I'll keep this physically attached to the mounting point, but I'll just disconnect the harness, plug it into this one to do the copy, and then we'll flash it over to this one. So it just minimizes the chance of dropping any screws and bolts and stuff because we will be using these very small screws and spacers. So I'm going to go ahead and do that now. With the ECU mounted, we can start reconnecting all the wires. On the 325, there is a extension for the regulator. This kind of felt like a weak fit. It wasn't really snapping in. I even tried squeezing it together with pliers, and I think it's just because the gasket's a little too thick. So I did squeeze it as much as I can as it clicks, and then I just put a zip tie on there. I did check the impedance, the voltage coming out with it connected to the battery, and it is good. So the instructions also say to secure with the zip tie, so it must be pretty known that that gasket's a little thick. Other than that, everything else is looking good. I'm just going to go ahead and start reconnecting everything. Be very, very careful when you are reconnecting your ECU. There's obviously a bunch of tabs in there, and the last thing you want to do is bend a pin, especially on your ECU side. You can see just how many pins there are in there, and if you damage one of those, it could be a very bad day. So I'm going to go ahead and start reattaching all the wires here. All of our electrical connections are good to go. The next piece is to mount the coolant expansion tank, or the reservoir, whatever you want to call it. And to do that, they give you a template here, so we just kind of line it up with the trim. I'm just mock putting the trim in because obviously the bucket and everything is not in yet. So you can see we're going to line it up here, and we're also going to drill 2 1/4-inch holes. There's a metal bracket I'll show you in a minute, but that's going to mount on the bottom side here for the coolant tank to sit in. So I'm going to go ahead and drill those holes. And there we have it, the completed install for the front section here. So basically everything we're doing from here forward is finished. We will be installing some, I have them over there, but the anodized aluminum throttle levers and things like that, but that's minor. We can get to that later. So the next thing I want to do is pull off the intake manifold. We will be shaving down the studs on here, and we're also going to be installing the manifold girdle, but we're also going to be installing the intake manifold upgrade kit. So it's much easier to do that stuff with the intake manifold off. I'm not really going to go into too much detail about how to shave the studs or how to put on. Actually, I guess I will show the girdle because I don't think I did a video on that, and I definitely did not do a video on the intake manifold upgrade kit, which is shaving out the side there. So I know this video is going to be long, so I'm going to try to cut out the stuff that I've done before, but first things first, let's get the intake manifold out, which of course I did make a video on that in the past. But let's go ahead and we'll start breaking this guy down. And just like that, the manifold is off. We have clean access. You see the back of the intake valves. So I'm going to start prepping the intake manifold for the stud shaving real quick, and then we'll get to the intake manifold upgrade. As you can see, these all can use some adjustments. We want to get it down to around 19. These ones actually aren't too bad, but I've seen them go up to around 22 or so, sometimes even higher. So I'm going to get these down to 19 flat, and then we'll put them back in. Installing the girdle is very, very simple. You just kind of loosen the threads. Get this out of here. Lift it just like that, and then you're going to put it over the space, the seam at the front of the intake manifold. See if I loosen these enough. Yep, just like that. And then we'll go ahead and tighten down each one of the bolts here. And then that's pretty much it for the brace. And then we'll do the manifold upgrade. Alright, first thing we need to do is remove the map sensor. It's just a single bolt holding that guy in, and then it'll pop right out. Just be careful. There is that gasket on there. And then next we're going to line this drill bit up on the 2 mounting posts that are already there, so it's basically going to sit on like that. I'm going to do that off camera just because there's some bolts I got to finesse with, but I'll show you what that looks like when I'm ready. Alright, so there we have it ready to go. It is on there nice and tight. So the next thing we're going to do is take our hole saw bit. By the way, Riva gives you everything you need to do this. So all this is basically just a jig to guide the hole saw. And you can see there is a hole in the front that this will slide onto, the center post. So that's just going to slide in like that. We'll go ahead and drill, and then it's just going to go through. Basically, we don't want to break this outer seal, and then once that piece is loose, the whole thing will just fall right off. And I'll show you what that looks like. So we'll pull this out, and then inside we'll have the flame / spark arrestor that we can just pull out. So let's get to it. And there we have it. That is the spark arrestor. You can see it here. It's kind of a pain to get out, so it's good to just use, I use like a trim remover and screwdriver to kind of just bend in the sides to be able to pull it out. But that's it. Super lightweight, but somewhat restrictive. People say that you can gain an additional PSI boost if you remove this. I haven't tested that, so not sure what I think about it. I might try it on mine eventually and do some data logging, but that's pretty much it. So before you do any work with capping it with the cap that they give you, you really want to clean this thing out, blow it out, use a leaf blower, vacuum it, whatever, because there's obviously a ton of plastic debris in there which you do not want going into your engine. So I'm going to take this outside, I'm going to file off the edges here to clean them up, and then I'll blow it out just to get that dust out. Alright, we have our cap in with the 2 O-rings and a small layer of grease on the O-rings just so they don't get pinched and damaged. Insert the plug. It's a nice tight fit. All we need to do now is take our 2 halves to secure it around the base, and then we'll tie in with our nuts. And there it is. This is the fully upgraded intake manifold. We have the IMUK, the bracket, and of course the shaved studs. So I'm going to get ready to put this back in. And of course, while we're in here, we are also going to be installing the Riva high flow fuel rail, as well as the VT1100 injectors. I'll show you how that works. But first things first, let's go ahead and get this intake manifold back installed. Alright, so I'm getting ready to prep the new high flow fuel rail to get it installed in the ski. I just wanted to explain a few things that are going on here. So this is the new fuel rail. We're going to be installing the VT1100 injectors. The injectors come with a black top hat that is not going to work with the ski that we're putting it in, so we need to swap out to these silver ones. And it's very easy. There's just a retaining strap on the injector here. It just pops off. The hat will pop off. Slide the new guy on. By the way, you do not want to do this dry. Use some fogging oil or something else just to lubricate those seals so that they don't get pinched or torn or anything like that. We'll slide the new hat on, put the retaining strap in, and that's what we're going to do first for the injectors. For the fuel rail itself, there is some prepping here. You can see that there is 2 different kind of fittings here. This one here, the 325, actually has a different fuel connector. It's just a push fitting, so you can push the fitting and it slides right off. On the 300 and prior, it was a kind of like a crimped connection, which is why they give you an Otecker clamp here and a bunch of different fittings. So we are not going to have to worry about that on the 325 since we only have the slip fitting. They also give you a fuel pressure sensor or just a readout. This is not to be used for riding. This is really only for testing. So I'm going to leave this out, and we are going to cap the end of the fuel rail. You're also going to want to use a kind of like a plumber's tape that's compatible with fuel systems. This one is. If you use regular plumber's tape, it could dissolve and cause problems, leaks. So you do want to make sure you're using something that's compatible there. And of course we have our adapters for the injectors. Since these are not OEM SeaDoo injectors, they obviously do not have the same connection type. So we're going to use these harness adapters to change that. And then we should be pretty much all set. They also give you some fittings, some bolts to secure the fuel rail. You can reuse the stock ones, but I'm just going to use these because they do have a wider head, which is going to give it some better fit. So I'm going to go ahead and do the rest of these last two injectors, get the hats upgraded, we'll get them fitted in the fuel rail, and then we'll go ahead and swap out the rail on the ski. All right, and there we have it. New injectors are in. I have it connected to the OEM fuel supply. We also have our injector harnesses in, so fuel rail is ready to go. I'm not going to press the injectors in yet, just because we will be doing a valve train upgrade as well as a cam install, which means I'm going to have to take the intake manifold off again just to get to that back port to be able to lock the crank. So for now, what I'm going to do is start to remove everything that's in the back here, just because we are going to be doing the JP Racing tunnel reinforcement, which means that all of these hoses need to get out of the way. So I'm going to remove the freshwater intake. The IBR is going to come out. We're also going to remove the siphon bailers and a few other parts that are in the way here, just to be able to make some room there. So I'm going to get started there. Alright, so I got most of the hoses out. I decided that I'm going to show you how to remove the IBR, but I'm not going to show you how to do the drive shaft removal just yet, because I do want to make that its own video, since that gets asked a lot, and tossing it in a 30-40 minute video, whatever this is going to end up being, is probably just going to get it buried. So I'm going to show you the process for removing the IBR. Now, SeaDoo does have a special tool to kind of sit on the IBR nut that's on the back of the hull in the transom. You don't need to use that. As long as the jet pump is out, which in our case it is, you could just use a pair of channel locks or whatever to spin that nut. So it's very, very simple to remove. You will need to cut this Otecker clamp and slide the boot forward or backwards. There is a piece that's holding this part of the IBR on, which needs to come off. Because the whole piece is not going to slide forward. It's really just going to be the back section, which starts from here to back, and the rubber boot is also going to come off with it. So really, it's pretty simple. We'll cut the Otecker clamp, push the boot, we'll take that little section piece off that I'll point out. I'll show you how that's done. Remove that nut. I think there's a 10 or a 12 millimeter on the inside, and then the IBR will just be completely free. There's just a wire harness, and then that's it. So let's go ahead, we'll cut this guy back off. And once that Otecker removed, we can see that this will now move forward. And if we go up far enough, you'll see that piece that needs to be removed. I know it's kind of hard to see on camera, but it's just a flat piece on the back. So we're going to hold that with some pliers. And then there's a Allen key on the front. So it's just these two pieces. It's just a hinge, so it's going to separate just like that. This rear arm will come off, and then we'll be able to remove the IBR there. So let me do that and I'll show you what I mean. Alright, here we go. So this is the back of the IBR where it attaches to your reverse gate. You have your pin, which slides through just like that, and then you have the retainer that sits in like that. And this is what's attaching to the IBR actuator, which is now loose. So you can see it's just the boot, and then we have the piece inside. So now we can take our channel locks, grab onto the giant plastic nut here, and we'll just unscrew it. It's not very tight on there because there is a O-ring and there's some sealing material, so it shouldn't take much at all to loosen it. So I'm going to do that and I'll show you what that looks like. Alright, this is kind of loose now, so I'm just going to loosen this and show you what that looks like. So there we go. This is the sealing piece, the actuator. I do want to point out that you will have this yellow gasket piece. You need to save this. This cannot get either replace it, or you do not want to throw this out. This is what's going to sit in this cavity, and that's what keeps the, it's like a waterproof seal. There's also going to be some marine sealant that we'll have to scrape off, and then we're going to reapply a fresh layer once we put the IBR back in. So on the back side we are all set here, and now we just have this, it's either 10 or 12, I forget what it is, and then the IBR will just slide forward and come right out. And there we have our IBR module. This is the, I forget what generation this is, but this is the latest. It's been this way for a few years now. Certainly a lot more reliable, but also significantly easier to service. For those of you that have not seen, you can disassemble these and replace the gears and the motor, which is pretty much all there is to it. There is also some circuitry in here, but that seems to be fairly reliable. That's pretty much all this is. So, by the way, I get this question a lot. This boot is actually a method to retain the internal air pressure of the IBR, because when this arm is going in and out, you obviously have that other piece on there. So when this is going in, you're going to build up a lot of air pressure. When it goes out, you're going to have negative air pressure. So this thing will expand and contract to maintain a stable internal air pressure. And you may wonder, why is that important? Well, you have the exterior side of this, which is part of the same inside air, which is under the water line. So if you have a negative pressure in here, it'll try to suck in water, which is obviously what you do not want. So this thing will expand when you have the IBR in, which maintains the air pressure inside. Therefore, this will not take on any water. So very clever design, works every time, but a lot of people ask what this accordion boot thing is, and now you know. Alright, so we're getting closer to being able to install the reinforcement. The next part is to remove the drive shaft, and like I said, I would put that in this video, but that's almost a full video in itself, just because it's a pretty important thing, especially for carbon seal changes and things like that. So I'm going to make that a separate video, but essentially there is a tool that will mount right here, which is this guy in the corner. This mounts across. This piece will mount onto, you can't see it in video, actually maybe you can just a tiny bit, but there is a nut in here that will rest on. And essentially we just turn the drive shaft from the back to loosen a nut, and that'll let us take out the drive shaft. On the older SeaDoos, there was a carbon seal with a bellows, or a stainless steel hat with a bellows that you had to compress to remove the C-clip to move it forward to pull the drive shaft. On the 325, and I think there's a few other ones using the threaded nut. They also used it years ago. It's significantly easier using the tool. Of course, you can also do it with channel locks in the front here, and then have someone turn the crankshaft or turn the drive shaft in the back. But I kind of like having the tool because I can do it by myself. So other than that, the only other piece that we really need to remove, or the other 3 bolts, are the bolt over here that's holding in the steel or the aluminum plate for the baler, this plate over here, and then we also have the front ride plate bolt. Now, I did do a ride plate install in the past, and I showed you that there is a nut that you can get to from under here, and a bolt that you have to access from under the ski. It's definitely a 2-person job. So I'm going to do all that stuff off camera, just because it is kind of time consuming, and I already showed it in a video before. But the next part after, we'll get into installing the the fiberglass reinforcement. Alright, with the JP Racing tunnel reinforcement installed, we can go ahead and start putting the IBR back in. So that's exactly what I'm going to do. The process is basically just the reverse of how it came out, with the exclusion or the addition that you want to use some kind of gasket material, marine rated gasket material, something that can be submerged. That's what I'm going to be doing for that. And we'll go ahead and get it slided in. There is a trick to getting the otaker clamp holding the swivel piece back on in the rear that I took off yesterday. I will show you that. So for this, you will need otaker clamps. You cannot use worm drive clamps for the IBR, and I'll show you that just in a minute. So before we get this all the way in, we're just going to go ahead and connect the wiring harness, just because once it's in there, it's kind of a pain to get to. Make this sure that's secure. Push the locking tab back in, and then we can go ahead and put the IBR through the hole at the rear, just like that. So that's in. I'm not going to secure this bolt yet. I will kind of pre-thread it just so that it doesn't back out on me, but we're not going to tighten it down because we're not sure where the final resting spot of the IBR is going to be. So we'll leave it like that for now, but we can put on our little wire clip just like that. All right, let's go back to the back side of the ski. By the way, guys, a trim removal tool, preferably one that has a sharper tip, is the best at removing the old gasket material, because you can kind of scrape it on there, and since it's softer than the material that the color is made of, the acrylic, it's not going to scratch or anything. Ideally, you should do this before you put the IBR arm back in, but it doesn't really matter. So I'm going to go ahead and clean up that surface real quick, and then I'll show you the next step. Alright, so the gasket material, you want to bead a smaller amount around the base of the IBR arm. You don't want to get it on the threads though. So it also helps to put a small amount on the gasket face here where that rubber sealant is, or just slightly on the inside before the threads. Again, the gasket should do most of the sealing with the water, but you want to have something in place just in case, because this is certainly not a part that you want to get water inside. You know, once you get water in there, it's just going to eat away, and then you're out a $800 or $1,000 IBR. So definitely want to make sure this is watertight. Alright, with the gasket material on, we can go ahead and thread this back in. We are going to just kind of hand tighten this, and I'm going to use my channel locks to go maybe like a half a turn beyond hand tight. You don't want to overdo it, because if you squeeze that gasket maker and the gasket itself out, again, you're just going to lose the waterproof, water resistant properties. So you just want it tight enough that it won't back off, essentially. So I'm going to do that real quick. Next step is to put a Otecker clamp onto the expansion hose. I made the mistake in the past of waiting until I screwed this thing back into place to put that Otecker clamp on, and then it's just a total pain in the ass. So put it on the hose first, and then you can reattach the arm. And by the way, guys, if you're doing any kind of work on a SeaDoo, it is absolutely worth getting yourself a clamp kit. It just comes with a bunch of different sizes. For the boot, I think we're using the 24 to 28 millimeter, which is that one right there. But even, you know, for the cooling system, we have clamps like that. For the PTO seal, they use these clamps. There's quite a few parts of the SeaDoo that you cannot use regular worm clamps on, or else they can cause problems, and this is one of those. So if you're doing any kind of work, it's absolutely worth getting one of these. I can even put it on the description, because I got this kit a couple years ago and it's been very, very useful. So continuing on here, so we have this clamp ready to go. It is not squeezed or anything, that's going to be after the fact, but we're going to go ahead and put this arm back on. So you remember what it was before. We're just going to unscrew this, connect the arm, thread this back in. It's not going to be super tight, obviously, because it needs to be able to swivel and move just a little bit, but we need to get that screw in there tight, and then this will be good to go. Alright guys, before I do anything else in the engine bay area, I think what I'm going to do is rebuild this pump, and what I mean is replace the impeller and the wear ring. I'm also going to add some gear oil to the pump cone. I'm not doing any bearing rebuild or anything here. It's a perfectly fine jet pump. Wear ring even looks perfectly fine as well. But either way, I'm going to be upgrading to the 1419 impeller. It's by Solas, a stainless wear ring, and we'll take care of that pump stuff in the back. Now there is a trick to this. Plastic wear rings you can normally beat in, but the stainless is a little bit more difficult, obviously. So what you can do is put the stainless wear ring in a freezer, just to kind of help it shrink a tad. And then we're going to use a blowtorch or just a can of MAP gas to heat up the jet pump kind of surround to expand it just a little bit. And if we do that, we should be able to get to the stainless ring to either just drop in place fully, or at least get partially started, and then we can kind of just bang it in the rest of the way. So I'm going to get started on that. So I've mentioned this multiple times before, but jet pump wear ring replacements and everything are very common, so it doesn't hurt to mention it multiple times. The first thing you need to do on a jet pump to get the impeller out is remove the tail cone, because there is a piece that we're going to put in the vise to get that out. But the first thing you have to do is remove the nose cone, which is this guy here. Most impellers will have this. Sometimes when people rebuild their pumps, they don't put these back in, but that just unthreads, nothing too difficult about it. So we can just put this down, and then we have our 3 T30 bits around the tail cone that have to come off. And as you can see, this is a factory fill, but you can see the reason I use gear oil is because the grease is nowhere near the bearing. Most of the grease sits in the cone, but it all gets flung outside of the bearing. So when this thing starts for the first time and it's, you know, it's getting warmed up for the first 5-10 minutes or so, the grease is more of a solid than it is a liquid, so that bearing is just riding around in there completely dry, which is why I always put that gear oil in there. And you can tell obviously that this is a saltwater ridden ski. The anodes are chipping away. But the ski is very well maintained. This guy does look after his stuff meticulously, which is, you know, another reason he's buying all very good parts and asking for the best stuff that we can put in here. So I certainly want to give him that. This is good to go here. All we need to do now is put this in the vise, and then we can use the impeller removal tool to get the impeller out. By the way, I did mention he's upgrading pump seals, so we can get rid of that garbage. We have a nice thicker one we're going to be installing. But with that said, we have our WR012 size impeller removal tool, and then we also have our 36mm socket. Put that on, we're going to break out the breaker bar, and we'll pop this impeller loose. There we go. Impeller is good to go. Pull that out, and you can see, I mean, this is the stock impeller, but it is very nice, just very small minor nicks, nothing that couldn't be filed out if we really wanted to. We'll put that aside, but the rest of the pump is looking good. So to remove the wear ring on this jet pump, not all SeaDoos are like this, it's mainly the supercharged ones, the newer supercharged ones. You have to remove this nut here, or this bolt, on both sides. It is just driven into the plastic wear ring to keep it from spinning. So you can either use a flathead or fit a socket to it. I believe it's an 8mm or something like that. But then we can go ahead and do what we normally do and just cut the wear ring out. One other thing, guys, what I like to do when I have the jet pump out is to ream the inside of the mounting post with a wire brush, just to kind of clear off the salty corrosion, whatever it is. So just a quick, just like that. You can see all that corrosion smoking right off. And now we have nice clean posts to mount the threads back in. Alright, just like my last video, there's quite a few ways you can remove plastic wear rings. You can heat them up with a torch until they melt and pull them out. You can heat up a screwdriver, cut them down the side. Or you can do what I do and just take a oscillating tool, cut down a line, and then just use a screwdriver to break it and pop it right out. So I'm going to do that real quick and I'll show you what it looks like. 5 seconds later, that's all it takes. So I'm going to use a screwdriver to kind of pop around here. It's probably going to be stuck in there because of all the salt. Yeah, just like that. And now it's broken loose. So that's all it takes. You just don't want to go too deep or else you'll nick the metal. But that's it for this. So what I'm going to do now is kind of clean the area around here, because I'm going to use a blowtorch, or just a can of MAP gas. I have it down there, I'll show you in a minute, to heat this up. But you want to be careful. You obviously do not want to hit the center seals, and you also need to be careful here because of the plastic intake mesh that powers the pump for the ski. So I'm going to get this cleaned up real quick and I'll show you what I'm going to do. So I can't do this with just 2 hands, but what I'm going to do is just hit the torch into one spot like that, and I'm just going to spin the pump with my hand just to kind of get the heat spread all the way around. So I'll get this thing turned on here just like that, and we're really just going to hit it and spin it. We want to get it to the point where we can almost feel the temperature through the mounting posts on the side, just to get it warm enough. Now I already have the stainless wear ring in the freezer. It's been in there for a day or two. Generally at least 6 hours or so should be enough to help the material shrink just a tad. Heating this up will expand it just a tad, which should be just enough to help us get the ring to just drop right in. So I'm going to get to heating this, and I'm going to run into the house to get that stainless ring and see what we can do. Yep, just like that. Locked into place. Very, very easy. Again, cold and heat, and you can see that the heat from the pump is transferring to the ring. So easy drop in. We'll let this kind of size to where it wants to sit. We'll get the pump, let it cool down a little bit just so I can touch it. It's kind of too hot to touch right now, and then we'll start putting it back together. All right, next we have the brand new Solas 1419. This is going to pair very nice with the Stage 2 tune. So it's probably going to be slightly tight there on the brand new stainless ring, but it should thread in nicely. Yes, it's absolutely perfect. Just like that. And then you can see that is a very very tight but perfect clearance between the impeller and wear ring. So I'm going to get this torqued to spec. I believe SeaDoo calls for 96 or so foot-pounds. I generally put up to 120 just because a little bit more is better in this situation. The last thing you want is your impeller unthreading under load because it'll push the drive shaft forward, which will put stress on your engine's thrust bearings. And at that point, it's game over. You might as well just buy a new engine. So even if over torquing could compromise the threads in the pump, which it does not, I've been torquing to 120 foot-pounds for many years. It's much cheaper to rebuild a jet pump than it is to rebuild an engine. But you know, like I said, I've always torqued to 120, going slightly over spec, and I've never had a problem. And I've also never had a impeller unthread on me. And also, you do not want to use any anti-seize on the threads on here because that will throw off your spec. I know some service manuals or owner's manuals, whatever, call to use it. Some do not, whatever. Generally, it's best practice not to use it. So at the same time, I service my pump center every once in a while, so I don't need to worry about the threads getting locked on there. So with that being said, I'm going to go ahead and torque this down to 120 foot-pounds. Next piece is the new pump seal. And you can see there, this is directional, so you want to put it towards the top of the pump. Top of the pump is where the baler system will sit. So it's going to sit just like that. We're going to keep it installed just like that. And by the way, guys, if you're using a stainless ring, you do not put in these screws to hold the plastic ring in place. There's no need to put these back in. I would just keep them somewhere safe in case you ever decide to go back. But in this case, we are not going to be using those. So this is pretty much good to go. All we need to do now is put on the nose cone. So I'm going to thread that in real quick, and then I'll show you how we'll button up the tail cone. And lastly, all we have is the 75.90 gear oil. We'll just go ahead and put a little bit in here just to make that bearing nice and happy. I tend to go just at the grease line, or about a couple millimeters under the first rubber seal, and you can see that the bearing is just eating that up. So put a little bit more in here. See how that does? Yeah, it is still sucking it up. So that's just how much of a cavity there was in the bearings, and they were running dry every time this pump is cold. So, you know, I guess that's why the newer SeaDoos that run on grease tend to have more frequent jet pump rebuilds than the older 90 skis, which can go for quite a bit longer before they needed to have the bearing replaced. So I found that every time I use the gear oil blend with the grease, I basically never have to rebuild these jet pumps. They seem to just last forever. So this is good to go. I'm going to let it saturate just a little bit more, and then we'll go ahead and put on the tail cone. And just like that, the jet pump refresh is finished. So we can technically put this all back together, but unfortunately, the steering / Venturi nozzle, because this is a salt ski, actually the owner did say this was broken from the factory, so I need to extract this bolt here. I could just thread this back on, because that's what I did here. I just kind of unthreaded it so I didn't have to break anything, but you know, I'm going to obviously fix it right for him. That way he can service it in the future very easily. So I'm going to extract this bolt first, but I'm going to wait because he did order a replacement. I'm going to wait for that to get here before I do anything else here. So that's pretty much it for this part. We are slowly working our way through the remaining list of modifications. So I think what I'm going to do next is put the cooling line back in, since we did the jet pump reinforcement, and then I'll be able to put the intercooler in. I'm going to keep the intercooler kind of loose. Actually, I'll attach it on the supercharger side, but I'm not going to attach it on the manifold side, because I'm still going to need to remove the manifold when I do the camshaft upgrade, because I need to be able to get to the crank lock. So we'll keep that part out. I can attach it and just pull the hose later, but it's kind of a pain. Actually, we'll see. I'm not exactly sure what I'm going to do yet, but I do know that I want to get the cooling lines set up back in here and install the intercooler just so we can get that part done. So here is the Riva intercooler. So this is pretty much drop in, ready to go. This will be the top side. So we'll have it basically installed like this, and this is a much thicker core than the stock, which is good. So we'll take these caps off. I think what I'm going to do is just install it as is, and then I will connect the upgraded hoses just so we have more room to work. But it should be a pretty straightforward install. There's no modification or anything that's needed to the straps or the mounting position of the factory intercooler. This is just a direct drop-in replacement, and then we can go ahead and attach our lower, upper, and the vent line, and then we can put the input and output for the connection hoses. So let's go ahead and do that. By the way, guys, quick tip to make your ski last longer. Before you put your intercooler in, I highly suggest spraying some anti-corrosion in the foam insert where the intercooler sits, just like that, because if you ride salt, this is actually a very common spot for the salt water to kind of collect, and then there's no real good way to get to it, to rinse it out, so it just kind of sits underneath, and over time it'll start eating away at the core of your intercooler. So put a nice thick coating of anti-corrosion spray in there, just like that, and you'll give your intercooler a nice bay to sit in, and it'll just help it last longer. I'm sure if you've ever taken your intercooler out, you'll notice we have this one here, which is our stock. I mean, this is in the back where you can't normally get to, but this is the top, and if you see on the bottom, there's significantly more corrosion on there. So that's exactly what happens. If you give it a nice bed of anti-corrosion to sit on, your intercooler will certainly last a lot longer. Intercooler is in, we got the cooling lines in, we got the vent line in, straps are in. Straps are a little bit more tight on this intercooler because it's obviously a much thicker core, but still is not too bad. So next thing I'm going to do is I am going to install the back and the front here. I'm just not going to attach the intercooler line at the throttle body, like I said, because we are going to be removing the manifold. So especially because I just want to get that back hose on. I probably could have put it on before I put the intercooler in just to make it a little bit easier, but I don't want to damage these hoses. They're very nice hoses, so we'll get it in there and we'll go from there. Next on our list is the blow-off valve. So we have to put this together. Very, very simple to do so. We just have our exit valve, decorative exit valve. We have the coupler, which is going to mate the flange on the intercooler tubing. Or the other side, we have our coupler. We have our vent connection. This will thread onto the top of the blow-off valve. And this hose will tie back to the intake manifold where we installed that aluminum adapter. Basically, this is what's going to read boost, so when the manifold is pressurized, it will push down into here and prevent the gate from opening. And then when there's no boost, basically when the throttle plate closes and this is in a vacuum state, this will lift up and vent all the boost that's built up in the intercooler hoses. So I'm going to put this together real quick. I'll get it attached to our intercooler hose here, and then we'll go ahead and install this on the ski. And there we have it. The blow-off valve and tubing are installed. And again, by the way, I did take the intake manifold off because in typical fashion, I dropped one of the mounting lugs that goes in here, and it conveniently landed underneath the engine, and the only convenient way to get to it is by taking the manifold out, but it had to come out anyway, so that's perfectly fine. So this is good to go. Next thing I'm going to do is the intake mesh. The owner does want to put in the ventilation mod that I did a video on earlier, especially because of the gains that it gives. So I'm going to be doing the same intake holes on either side here, as well as on either side of the tub for the storage up here. So I'm going to do a 2-inch hole. It's a 3-inch frog skin with a 2-inch hole on either side here, and then 2 in the front. So I'm going to go ahead and knock that out real quick, and then I'll show you what the final product looks like. And just remember, before you do any kind of sticker application or whatever, when you are cleaning the holes up to apply the frog skins, you do not want to wipe down your surfaces with rubbing alcohol or anything that's going to damage the acrylic. Rubbing alcohol will cause this to spiderweb and make all kinds of weird looks and everything like that. You can use rubbing alcohol, but you have to dilute it. I think the call is 2 to 1, so it should be basically less than 50% concentration of rubbing alcohol. I don't even risk it. It's, you know, the acrylic, it's very prone to cracking with any kind of rubbing alcohol. So I'll just wipe the surface down, and then I'll get a wet rag with a little bit of water to clean the surface to prep it. Obviously, I'll be washing this ski when it's done because there's fiberglass everywhere, but for this, definitely want to prep the surface without using any kind of rubbing alcohol. And there you have it. That is what the frog skins look like when they are installed. We have the back ones, front ones on either side. And basically, you know, I did mention it in the other video, but you have the air coming in just under the plastics, so it'll very easily get into this spot here. But there's also air that's going behind this whole channel when all the plastics are in, and you're introducing fresh air into this cavity here, which of course can be used by the rest of the engine. Now, a lot of people will say, you know, what could these vents possibly be doing? There's no way these are effective at all. And I challenge that. I've actually tested them, and I was able to gain let's see, 5, 6, 7, almost, you know, 2 miles an hour on mine with an additional 400 or 200 to 300 RPM just by getting additional air into the hole. And you know, like I mentioned, when everything is closed up and you have all the trim on and the seats on, these are the only fresh air entrances into your hole. And of course there's even plastic on top of this, so it's even more restrictive. It has to be restrictive. You're a watercraft, you're very low to the water, highly maneuverable. There's only so much they can do for fresh air ventilation. And Riva actually has a video. Realistically, you can see it on any SeaDoo video that the engine's revving on land. You can see the hole being sucked in because there's just so much suction with these engines. And of course, in one video I did go into detail on the math about, you know, how much CFM these engines are using and the whole air exchanges, whatnot. Basically what it came to is any kind of additional ventilation you can get to your ski is going to be beneficial in some way to performance. So certainly worked for me. If you don't believe in putting additional holes in your hull, you know, by all means, there's no need to do it. But if you are someone who's chasing top speed and you want to get the absolute best performance, there's no other way around it. You have to get fresh air into your ski at some way. And this is just one easy way to do it. It's very discreet. You can't really see it when everything is buttoned up. You can just barely see the edge of this under the plastic trim in the front. But that's it for that. So I think what I'm going to do next is get the depth finder ring started down here. I'm not exactly sure how I'm going to get the depth finder to fit because it's supposed to sit pretty much right where the JP Racing tunnel reinforcement is sitting right now. So I'm going to play with that a little bit and see what I can find, and I'll show you what I come up with. Alright guys, so that spot right there is the place I came up with. I've been checking for probably 20 minutes now to find a spot that'll work. There's no way at all it's going to work in this area here because there is a difference in height in the hull right here. The JP Racing reinforcement comes up too far for it to be a flat surface to sit on, so there's no chance it can sit there. It can't fit up in this cavity here because the water box is in the way. I looked even in the further back to see if there's any way I can make that work, but the ride plate's under there, so that's not going to work. I was even thinking about doing it somewhere up in the front here, but aside from being completely inaccurate readings, because this part of the hole would be out of the water, there's also no spot to mount it, so I decided to put it just under the footwell over there. For those of you with the Fish Pro, that's where your secondary battery will be located. And if we look at the water line, this is always going to be under the water, so it should have the same amount of reading accurateness or accuracy as if it was on this side over here. So it's slightly higher, of course, so the depth readings may be off by, I would say, what's that, a 4 or 5 inch difference, but for open water riding, that's not going to make a difference at all. So once that cures, this is the Fast Cure 5200. I'll get that all mounted. We have the gel pad and everything else we need. I'll let the owner know that we had to compromise on the mounting position. I'm sure he'll be perfectly fine in exchange for the pump tunnel reinforcement. But you know, these are the things we have to kind of account for and make adjustments for as we're going along. So that's pretty much it for that. The next thing I'm going to do is try to extract this broken bolt. Not sure how much luck I'll have there, but we'll see what we can do. So worst comes to worst, we'll just buy replacement housing here, but I don't think we'll get to that point. I'm going to try to do an extraction on that, and we'll see what we can do. Alright guys, it's been a couple days. Just wanted to give an update on where we're at. We have pretty much everything in the front done. Everything's put back together up here. Intercooler is in. I have the bucket for the depth finder installed, but the depth finder is not installed yet. I'm going to wait until after I do the engine work because you know, the wiring and everything is going to be routed here. Intercooler is done, obviously. Reinforcement is done there as well. I have the jet pump mostly put back together, or at least installed. The only thing I did not put back in is the steering nozzle, because like I said in the beginning of the video, this came broken from the factory. You know, just a poor install. The stud was snapped, and I tried doing an extraction on it, but I think they cross-threaded it, and that's why it broke. So trying to do the extraction didn't work. Ended up just cracking the housing. So I have another one on order. It's going to be here probably tomorrow, so I'll finish up the jet pump tomorrow. Today, all we're going to do is install the Riva Racing billet aluminum throttle and IBR levers. So I'm going to go ahead and knock this out. And again, I did make a video on this in the past, so I won't go into too much detail, but the process is very simple. We're just going to remove the front trim cushion thing here. I already have the bolts out in the front. We're going to see I believe it's an 8mm or 5.5, I don't remember, bolt that's holding in the plastic trim here, and then we'll have pretty much immediate access to the levers once we get this trim out. So very, very simple to get to. This is something you can do in, you know, 5-10 minutes. So I'm going to knock this out real quick, and then I'll show you what it looks like when it's all finished. And if you look at that, guys, you can just see how much nicer the billet aluminum handles are. These are also, I'm not sure what the coating is, but these do not get blazingly hot in the summer. I know that question comes up a lot. If this is sitting outside, will it get super hot? No, it will not. It's very, I mean, it's a heavy aluminum, but it does pretty well at dissipating heat, and it doesn't absorb as much heat in the sun as you would think. So I'm going to swap this out. And don't forget, guys, if you were doing this yourself, make sure you put some grease in the center here, some on the contact point for the spring, and then some in the hinge, the pivot as well, where it connects to the hull sensor. So I'm going to pop this one out, pop this in, put a little bit of grease in there, we'll be all set. There's the left side installed, and this is a Riva one, by the way, and this is certainly a lot more stiff than the factory plastic one is, but it has a really nice spring rate, so I can imagine this is going to feel quite nice on the water. So I'm going to go ahead and knock out the throttle side. And there it is, the finished levers, the Riva billet aluminum levers. Much more aggressive grip there as well. So, by the way, I did finish putting the trim on the front, and you can just barely see the end of those frog skin vents on either side. Actually, that one you can kind of see a little bit more of the venting, but that's really what I was kind of getting to when this ski's going, you know, whatever speed it's going at. All of the air is normally just going to be kind of going around here. It's very aerodynamic on the front, but the air will be directed through here, which just gives it an additional ventilation point. And like I said before, the goal is not to really force air into the intake, which is going to be sitting back here. It's not a rim air setup by any means. It's really just to get some additional ventilation points for the ski so that the engine can breathe. That way we don't just have those two restricted intake points at the front. So that's it for that. We are getting close to finishing up the modifications for this ski. Really, all that's left is the engine work. So this ski will be getting intake and exhaust valves, as well as a Riva Cam and the upgraded springs and retainers. So I was trying to figure out how I was going to do this on video, because I really wanted to show the process for upgrading springs and retainers, as well as installing a camshaft. But normally, if you are doing valves, you kind of just do everything at once because you have the head off. So I think what I'm going to do is keep the cam or I'll just keep the stock valves and everything in there as I'm doing, or the stock springs when I'm doing the valves. I'll put everything back together, and then I'm going to show you the process of installing the valves, the valve springs, retainers, and the camshaft afterwards. Just because, you know, many people are doing camshafts as well as springs and retainers. Not many people are doing valve work, valve jobs. So I definitely want to have a video for that. So I think I'll do that. So I'm gonna knock out the valves today, and then tomorrow I'm gonna go ahead and come back to do the springs, retainers, and the camshaft. Alright guys, it's the next day, and as you can see, the valves are in. I lapped the valves, got them all tied in, nice and shiny and new. So head's all torqued down, everything's good to go. So I'm going to start the process of installing the springs, retainers, and cam. But first I wanted to explain something about the springs, retainers, and cams and all that stuff. So on a SeaDoo engine, or really any engine for that matter, if you're going to be increasing the RPM beyond a certain amount, so for the most part increasing the RPM by 200 to 500 RPM or so is relatively safe on stock springs. You don't have to worry about it. You're not going to experience what's called valve float. But if you are going beyond a certain safe limit, which is, there is no like predetermined safe limit. It's just that with trial and error, people have to determine what's considered safe and not. On a SeaDoo 300, most people will run up to around 8,500 RPM or so before you have to consider doing springs and retainers. On the 325s, you can go quite a bit beyond that. On mine, I'm running 8,600, 8,700 on stock springs, and there's just really no need to go beyond that. There's a couple things to consider. If you are going to a much higher RPM, you really want to consider doing springs and retainers, because what it's going to do is if you have a heavier spring, it's going to be able to push the valve back or whatever a much faster or much more aggressively than a stock spring can. So basically, if you rev the engine to a certain RPM, to a much higher RPM, that valve may not have enough time to go back to its resting spot before the piston's already on its way back up. And that's what's called valve float. So basically the valves just don't have enough time to make it back because the spring isn't aggressive enough. If that happens, your piston can make contact with a valve, and that's just a bad story all over. You can destroy valves, you can bend valves, you can break the valve stem off, and then just have the valve head floating around in the combustion chamber, and it'll just destroy your engine. But the other side to that matter is, if you go too aggressive of a spring, you can actually break the rockers, and I'm going to show you that in a second here. The 325 does have forged rockers, but I think it's only on the intake side or only on the exhaust side. I forget which one was upgraded. The other side is not, but it was also a consideration on the SeaDoo 300s, because broken rockers are common if you're riding too much of an aggressive cam and too much of an aggressive spring. So it's really a gamble. At one side you are increasing the reliability of the engine at higher RPM, but then you're also putting stress on additional components. The other consideration is, if you have a heavier spring, that's more mass or more stress on the engine in terms of load, because now the crankshaft, the crank, the cam, the sprint, the timing chain, they all have to move slightly harder to compress the springs for each one of the valves. So there's a slight horsepower loss if you increase your springs. I'm not sure what it translates to in the real world, but it's just one of those considerations. So in this case, the owner is going to be running a Riva Stage 2 for the 325. It does not call for springs and retainers and all that stuff, but since he's going to be running a Riva Cam, which is slightly heavier, or slightly more aggressive, I should say, the springs and retainers are a must. So I'm going to pull this off real quick, and I'll explain basically what I'm talking about. And this is with the valve cover off, and you can see a little bit more of what I was referring to. Actually, let me get a small screwdriver here so I can kind of point things out. So this is our rocker arm assembly. This is what's actually making contact with the valves to push them down. We have our spark plug tube seals, which easily come out. We have our cam gear, timing chain, and then just underneath is our camshaft, which we'll be upgrading, as well as each one of the valves with the hats and springs and all that stuff. So whenever we're increasing the RPM to a higher amount, this, everyone says they have to do, do a valve train upgrade or whatever. This is what they're referring to. So the faster the engine is spinning, the faster these components are moving, and therefore you have to consider these when you're doing an engine upgrade or when you're going beyond a certain RPM. So since this guy is going to be running a upgraded camshaft, I'm not sure if we're going to go much higher than whatever Riva calls for the stage 2 in terms of RPM. But since the camshaft is much more aggressive, the lobes are going to be wider. It means the valves are going to be making more travel. With that in mind, since they're going to be making more travel, we need to beef them up so that they can return back to their rest position before the next cycle in the engine. So to do that, all we're going to do is first we remove the valve cover, which we already did. We're going to pull the spark plug tube seals, which are just these guys. And by the way, I did make a video on this, but if you ever are doing a basic service on your ski and you notice that there's oil in the spark plug tubes, these are the things that are going bad. It's been the same part number for probably 20 something years now. It's very common failure because it's rubber. Over time, the amount of heat cycles this thing undergoes, the rubber just kind of dry rots or shrinks, and that's how you get oil inside your spark plug tubes. So very easy to replace these. You just take your valve cover off, pull these, put a new set in, valve cover on, you're all set. But for this upgrade, what we're going to do is remove the spark plug tube seals. I want to put the engine in timing. So this is your, let me see, put the GoPro scene. This is your camshaft gear. There's going to be 2 marks on here. So I'm going to put the engine in timing. So we'll have the 2 marks that are basically at the top here. And that's going to have the least amount of stress on the camshaft, cranks, all that stuff. So basically what I'm trying to get to is we don't want to remove the rocker assembly when one of the springs is under tension, because what can happen is if say one of the back springs here is under tension. Well, if I remove this rocker, this, all the force is now going to be pushing on one of those rocker pieces, and you can break something in the assembly here. So I'm not sure why Riva doesn't mention anything about that. It's pretty common for anybody doing engine work to put the engine in timing, or at least close to it whenever they're doing valve train work. That's what I'm going to do. There's a couple ways you can do that. You can basically just spin the engine from the supercharger with the spark plugs out, of course, or you can spin the jet pump assembly until you see the 2 marks on the crankshaft here. So I will be showing that. I just want to give as much information now as I can so you know what's going on as I'm doing it. So since I'm doing the camshaft and the springs and retainers, what I'm going to do first is knock out the springs, and then last I'll do the camshaft. That way we don't have to worry about timing or anything like that, because doing spring jobs on a SeaDoo is very, very easy. There's really not too much to it. Riva does have a tool to make this super easy, which I'll show you. So really, you just need the Riva tool and a decent air compressor that you can rely on. Essentially what we're going to do is, once we get the rocker arm assembly off, we're going to mount the Riva tool to each one of the cylinders. So first we'll start here, and then we'll do the middle, and then we'll do the last. So we'll mount it here first. We're going to pressurize the combustion chamber. That's going to put a lot of force on the valves so that they don't move. And then each one of the valves, or each one of the springs, will have a tool that's going to push down on it. So it'll only push down the spring. It's not going to push down the valves. We'll be able to pull the keepers out. The keepers basically just keep that hat on top of the valves, or on top of the springs. And then we'll be able to take the spring out, put the new assembly in, crank it, and we'll proceed. So we'll knock out all the springs that way. Aside from that, that's pretty much all we're going to do for the springs. It's not difficult at all. It's just, you take your time with it. I'll show you a few tricks to make sure that you don't drop the keepers. There's a few oil returns up in the head here. If you drop a keeper down there, it's very bad. You're going to end up needing to pull the engine, or you can risk it and ignore them. But what I'm going to do is just put some like a rag or like a sponge or whatever in there, just to keep the keepers from dropping in case they ever do that. And then we'll get to doing the camshafts last. But as you can see, it's very clean in here. This is a, I forget how many hours on here, but it's a 325 2024, so it's very, very new, well kept, obviously. So first thing I'm going to do is I'm going to pull the spark plug tube seals, and I'm going to spin this over to get it into timing, and then I'll show you what that looks like. Alright, so the method I'm going to use to spin the engine is to just turn the supercharger nut. On the 325, it's going to be a 10 millimeter. On the 300s and prior, it's a 17 millimeter. So we're just going to put this on the supercharger nut there. And again, you want to do this when your spark plugs are out. You do not want to spin the engine via the supercharger whenever there is compression. So you can see we're just going to spin this super slowly, and I'm not sure how well that's coming out on camera, but the engine is spinning over. So I'm going to speed this up, and I'll come back once it's at top dead. And there you can see the two marks that I was mentioning. So engine is at top dead center in time, and you can see that we have the camshaft locking tool, which is able to go all the way down and lock in place. So we're basically at a point where each one of the valves is not under tension, which is very good. So now we can go ahead and remove the rocker arm bolts, and we won't have to worry about anything breaking here. So I'm going to go ahead and pull those off. All right, we have each of the bolts out. So now the rocker assembly, we'll just go ahead and lift out just like that. All right, guys, here is the setup that we have. So we have the Riva valve train upgrade tool, or spring retainer tool, whatever you want to call it, installed. We're just using the threaded inserts that the valve cover would thread into. We have it lined up with the camshaft. That's what these red marks are. I have the air compressor hooked up. Now when you're doing this, you want to use an air compressor that has a decent, at least a decent quality or decent quantity tank size, or at least one that can fill up fast enough, just in case, because the last thing you want to happen is the cylinder dropping compression when you're doing a valve job, because if the valve drops, you have no choice. You have to remove the head in order to properly reseat it. So I have a rather large air compressor hooked up here. You definitely do not need one that large, but it has a fairly decent tank size, so I know that I can fill this up and not have to worry about it. I also blocked off any of the drain ports where oil could go back into the block. That way if I drop a keeper, it's just going to sit in the head and I can easily get to it. So it's not going to be hard at all. And what we're going to do is basically just slide this into either end here. We're going to thread this in so that the valve will depress. We're going to take the keepers out. We'll unthread this, which will release the valve, the keeper, and all that stuff. And then we're going to put the new set in. So that's what we have here. We have the new springs, the new base, and the new hats. So the orientation for the spring does not matter, but the hat does. As you can see, it is tapered. And of course the base matters as well. It's also tapered there. So that will just sit in the spring like so, and that's how it'll sit in the base. So pretty easy to do this. Again, once everything is out, it's really just kind of making sure the cylinder has compression or compressed air, pushing down the valve spring, releasing the retainers, which will then free up the spring and the base and all that stuff. So we're going to do this one cylinder at a time. So obviously, and by the way, it doesn't matter which side you start on. I'm probably just going to start on the intake side, which is this side. I'll knock these two out, then we'll go to this side. We'll let go of the air in the combustion chamber. Then we'll move over to the next cylinder and we just repeat the process. So we just basically do this until we get to the end. And it's really not difficult at all. You just want to do it slowly because, again, all that's holding these valves from dropping is the air pressure. So if you are using the tool to thread in and you're accidentally pushing on the valve, you'll break that seal and the valve will just drop. So you just want to do it slowly. Basically what I'm getting at is do not, unless you really know what you're doing, don't use one of these tools. Use something you can control very slowly. Manual tools only. Unless you're feeling comfortable, then that's a different story. But I'm gonna get started here. I'm going to fill the combustion chamber to, I would say, 75 psi. The maximum is 80. That's what this is rated for. I'll just do 75. Again, we're going to fill it slowly, and then we'll get started on this. Alright guys, first cylinder is done. We have both intake and exhaust valves ready to go. This is something that, you know, no matter how many times you do this, it's far more beneficial to take it slow, because, you know, you drop one small piece and it can complicate it by many hours. So take your time with this. Riva estimates up to 3 hours. I don't think it takes that long. I would say, you know, an hour you can have the whole engine done, but definitely want to take your time with this. The two intake valves were perfectly fine. Exhaust valves were giving me a problem where when I was using the tool to drive down and compress the spring, the entire valve was going down. So I just had to use the ratchet to just do it real fast to kind of rattle it loose, and then it was perfectly fine. So we're good to go here. I'm going to remove the tool and we're going to move on to the second cylinder. And there we have it. Each one of the Riva springs and top hats and everything are in, and we are good to go. I didn't drop any keepers, but still had the rags in there just in case. So next thing I'm going to do is replace the camshaft. We're going to be using the Active Jet cam. It's in the box still, but we're going to pull this one out. We'll get the crank locked and everything. I'll show you the process for that. But when you are doing springs and a cam, you generally want to do the springs first. It just makes it easier. But other than that, that's pretty much all there is for the spring upgrade. I was trying to get video of the actual process, but you know, as I'm doing springs, I generally have my headphones on because the air compressor will randomly kick on, and if it kicks on when you're doing the keepers, it'll probably scare you and the keepers will go flying. At least I know it will with me, so I just wanted to focus on this so I didn't lose any parts. But yeah, I'm going to get the process ready. I'm going to start staging the cam, get it ready, and then I'll show you what we need to do for a camshaft upgrade. First thing we're going to do is remove the crankcase breather, PZV, whatever you want to call it. So I'm going to snip this zip tie. There's two Torx bits holding it on, one on either side, and there's two wire harnesses. I'm just going to get that out of the way. When I'm pulling this off, you just want to be really careful because there's a metal kind of like retainer pad thing in there. I'll show you what it looks like. It will be coming out, so we just have to pay attention to that, because if it drops in the engine, it's a total nightmare to get out. You're basically not going to get it out. So when you pull the breather out, just try to pull it out straight and slowly, so that if that metal tab is not snapped into the plastic cam gear, it doesn't just drop in the engine. So I'm going to go ahead and pull this off now. And with the breather off, you can see that metal plate in there that we need to get out. So I'm going to use a magnet, one that looks like this, to stick it on there as I'm using a screwdriver to pop it loose. That way when it pops out, there's no way it can drop, or at least it won't drop. It'll just stick to the magnet and then we can lift it out. So I'm going to do that now, but I'm going to do it off camera, obviously, because I need to really focus on not dropping that. Okay, with that off and the plate out, we're going to go ahead and lock the cam in place. Obviously you can see it's not in timing anymore, because when we filled the combustion chamber with compressed air, it just spins it. So I'm going to crank the engine over until this lines up, until our camshaft locking pin drops into place. Alright, the cam is in time. We have the lock in place. Next step is to take out this plug here on the bottom of the block, and we're going to put the crank lock in, which is this guy here. So we'll have to unthread that and then drop this guy in until it locks in place. We have our crank lock in, and it's good. I tested it on the supercharger with just, you know, a tiny amount of force just to make sure the engine doesn't spin. The engine is still in time, and I also put a rag in here because we're going to go ahead and remove the camshaft bolts. There is 3 of them, if you can see them. But there's 3 in there, so we're going to remove all 3 of those. Just kind of loose it first, and then we'll go ahead and take out the tensioner, but I'll remove these first. Alright guys, the chain tensioner is held in there with a T50 bolt that comes right out, and then we're just going to use the magnet, lock on there. Yep, there it is. Just pull this out slowly. There we go. So this is the hydraulic tensioner. We are going to have to relieve tension on this before we put it back in, and I'll show you how to do that. Actually, I'll show you how to do it now before we do anything further. So let me readjust the camera. So we have our tensioner here. We could just take a flathead screwdriver or something that fits inside this, and we just want to push on it just like that. All the oil will start to come out, just like we're seeing there. It may take a few tries, but just keep it this. You want to relieve all that pressure from the oil until nothing comes out, and then it's nice and springy. So yeah, that's already much better. That's what we're looking for. So I'm going to keep doing that a few times just to get the oil out. That way we have a fresh tensioner we can use when we put everything back together. All right, now we can remove the cam gear. First I'll pull out the guide just to get that out of the way. Of course, this will be slightly a pain. I'm going to try to do the cam gear just to loosen it, and then I'm going to pull the guide out. This part I'm going to do off camera just because I need the room, but really we're just trying to get the chain behind. That way we can get the gear out. Now that we have the cam gear out, we can go ahead and pull the cam. We're just going to pull the locking tab that's on the back that just keeps the cam from moving back and forth, and we'll just slide it out. So there's no bearings or anything for this. It just kind of sits in the face of the head, which means you want to be very, very careful when you're pulling this out. It should move pretty freely, but if it binds, just kind of shake it a little bit. There's plenty of oil on here, so it's not coming out dry or anything like that. I'm sure that's not working because of my hand is in the way, but there we go. And there we have it. That is the factory camshaft. So I'm going to go ahead and prep the replacement, and I'll show you how we put that in. Alright, and here is the Riva Cam. This is certainly a nice upgrade. Now obviously we're not going to put this in dry, so I'm going to use some assembly lube. I'm just going to put it on, rub it in, and then we'll go ahead and drive the camshaft in. With the cam in place, we have it locked, so it should be on time now. So we're going to go ahead and get the cam gear in. We're not going to tighten it down. I'm just going to get it in place and then partially thread them using like a semi-permanent to more permanent Loctite. We can remove it, but we want to make sure that it's not going to back out. So again, I'm going to get the gear on. We'll try to get it as close to timing as we can see, and then we'll make the adjustments after. But I just want to get this in with the chain on, basically. Alright guys, so we have pretty much everything in here. I was able to rethread the nuts. Now the goal is to get them in but not to tighten them. As you can see, the cam gear is still loose. What we're going to do is put in the hydraulic chain tensioner. We're going to reinstall it, get that all set, and then once that puts tension on the chain, then we'll go ahead and tighten it to get it just in place. Because basically what's going to happen is, if we tighten these now and then put in the chain tensioner, there's going to be slack on the backside. It's going to be slightly out of time. So we just want to get the bolts in the cam gear just to hold it in place. We'll put the tensioner in, and then we'll go ahead and tighten these down. So tensioner is ready to go. I already drained all the oil out of it. As you can see, it's very loose. So I'm just going to put a little bit of assembly lube on here just to, give it something to work with. We're not building a fresh engine, so we don't have to be super careful with this. But basically, this is just going to go back in the engine. It's going to be flat face inward, and then this open side will go towards the back where the bolt is. So I'm going to do that real quick. Alright, now that I have that tensioner in, you can see this is nice and tight, so we can go ahead and crank down those bolts. That's exactly what I'm going to do now, and then we'll go ahead and just put the chain guide back in. Alright, we have the metal plate inside the cam gear. We have the chain guide all set. So really I just need to remove the crank locks, and we pretty much should be good to go. I'm going to get the rocker arms ready, so I'll put that back on and I'll show you what it looks like. So for the rocker arm bolts, we're going to use new ones. You cannot reuse the old ones. Not much to these. Riva does give you the torque spec, so that's what I'm going to follow. In fact, I have it up here. So they give you the sequence as well as the spec. The spec is of course 7 foot-pounds, which is 10 Newton meters. And then we'll do a second lap, bringing it to 14 foot-pounds or 20 Newton meters. And then we'll finish it off by going 90 degrees off of whatever the finishing tech is. So not too bad. I'm going to knock this out, and then I'll show you what it looks like. we are pretty close to being done. We got the rocker assembly in, we got the spark plug tubes in, the seals on the outside are all put back together. Now all we have to do is put the valve cover back on, put the breather on, the sensor back in. This will all be done here, put the spark plugs in, and then it's really just put the intake manifold back on, and the ski is pretty much ready to go. The only thing I'll need to do is, of course, put in the depth finder. And of course, since this is running a Riva Stage 2, but with bigger injectors, a cam, Riva is going to send us a custom tune for this, which is actually, it's already pre-made, so they're just going to send it to the map tuner for us. And then this ski will be ready to go. So I'm going to go ahead and finish up what needs to be done here, and then I'll show you what it looks like. And there we have it. Everything is buttoned up, everything is reconnected. The only thing we need to do now is basically reprogram the ECU. So like I said, we do have the Riva Stage 2, or the Riva Unlocked ECU that we're going to be running the Stage 2 tune on. So I reconnected the old ECU. There's a bird in here, flew in by the way. We're going to get the map tuner connected. We need to copy the original ECU data. We'll plug in the new ECU, and then we're going to transfer the data over, and then that way we can load the tune. So we're kind of limited right now. I'm going to flash the Stage 2 tune. Even though it's not the right Stage 2 tune, I have to wait for Riva to send to this whole ID number. But I can at least get it up and running. And then we're going to do a IBR recalibration, since we did do the IBR stops. So I'm going to get this process started with the ECU cloning. Alright guys, we have the ECU in, it's programmed, we have everything lined up here, so you can see on the programming that we do have the 9300 RPM tune loaded. The only thing that's missing is the VT1100, so we have to wait for Riva to send us the file for that. But other than that, everything else here is good to go. So I'm going to go ahead and connect to buds just so we can do the IBR calibration, and then we should be all set. Alright guys, as you can see, everything carried over here. Of course, you know, the batteries in these things suck. I'm already getting low voltage codes, and it's literally sitting on a charger, so I'm going to try to do this quick. But everything carried over. We cannot do the module updates with the unlocked ECU, or else it will brick it. So all we're going to do here is go to the auto calibrate IBR. We'll do the auto calibration. Gate is attached. And there we go. So the calibration is complete. We can be finished here in buds. By the way guys, I made a mistake. This key is not a duplicate key to be programmed. This is for his other ski, so I got to do some work on that. But this is all set here. I'm going to go ahead and put the top deck back on, let the charger sit on here for just a few to let it gain a charge. But we just really have to wait for Riva to send us the updated file. It'll be directly to the tuner, so there's nothing we need to do. Once they send it to this, all we have to do is connect to map tuner, see the tune there, and we'll just flash it to the ski, and everything will be good to go. So that's pretty much it for this video. If you guys have any questions at all, please feel free to let me know. This was a full, basically everything Riva had to offer for the 325 has been installed, including the exhaust and everything, but that was already on here. So not too bad. This took about a week, but it's really only because I'm only working on it after work. So if you were doing this on a weekend, you can absolutely knock it out on a Saturday and Sunday. Not too bad at all. So if you have any questions, please feel free to leave a comment or send me an email.